The question of whether something can come from nothing is a deep and complex question of interest to physicists, philosophers, and astronomers. In a scientific context, this question often changes our understanding of the origin of the universe, especially when it comes to events related to the Big Bang and the nature of empty space. Physicists approach this concept by considering the concept of nothing. In the classical understanding, emptiness is the absence of matter, energy, and even the laws of physics. In quantum mechanics, however, the situation is much simpler. Quantum field theory suggests that what we perceive as empty space is actually filled with fluctuating energy and virtual particles that briefly appear and disappear. This means that even in a vacuum, which is often considered nothing in the conventional sense, energy can fluctuate and lead to transient phenomena. Some interpretations suggest that these fluctuations could potentially give rise to the universe itself. One of the attractive ideas of modern cosmology is the concept of quantum fluctuations leading to the creation of the universe from a vacuum state. The theory suggests that under certain conditions, a region of space can undergo fluctuations strong enough to create matter and energy, leading to a large explosion-like event. This notion is consistent with the prospect that the universe could emerge from a state of quantum nothingness, where the laws of physics allow for spontaneous creation without the need for a pre-existing cause. Furthermore, investigating the nature of time complicates the question of its origin. If time arose along with the Big Bang, then the idea of before loses meaning, raising questions about causality and how we define creation. Some theories suggest that the universe may be part of a larger structure in which cycles of expansion and contraction may occur, suggesting that the universe may exist in different states over time and potentially create itself repeatedly. Overall, although the idea that something can arise from nothing challenges our intuitive understanding of existence, physicists are increasingly exploring these topics with advanced quantum theories and cosmological models. Ongoing research into the origin of the universe illuminates these intriguing questions, stimulating efforts to bridge the gaps between physics, philosophy, and our understanding of reality. The question of what was before the Big Bang presents a paradox rooted in our traditional understanding of time. The Big Bang is commonly viewed as the event that marked not only the beginning of the universe, but also the origin of time itself. In this context, time is seen as a dimension resulting from this single event, meaning that prior to the Big Bang, the concept of time as we know it may not have existed at all. This challenges traditional notions of causality and chronology. In a system where time is linked to the fabric of spacetime, the concept of before becomes undefined. Without time, there is no temporal flow or sequence of events, making it logically meaningless to discuss what might have happened before the Big Bang. The absence of a prior time implies that our language and understanding of events is limited when attempting to describe the conditions preceding the Big Bang, or any state that could be conceptualized as earlier. Various cosmological theories attempt to solve this problem. Some suggest that the universe may be part of a cyclic model in which it goes through endless cycles of expansion and contraction, suggesting that time may extend beyond the individual events of the Big Bang. Others explore concepts such as the multiverse, where our universe is just one of many, possibly existing independently of the time frame in which we live. It follows from these models that even if time began with the Big Bang, there may be alternative frameworks or broader contexts that offer insights into existence beyond our usual perception of time. Ultimately, thinking about what came before the Big Bang illustrates the limitations of human understanding when confronted with the fundamental mysteries of creation and existence. This emphasizes cultures and religions have a variety of creation myths that often reflect their unique worldviews, values, and understanding of existence. These creation stories usually address fundamental questions about the origins of the universe, life, and humanity itself. As scientific theories about the origin of the universe, particularly the Big Bang theory, have evolved, many cultures and religious traditions have sought ways to reconcile these scientific findings with existing beliefs. In some cases, religious interpretations may use scientific findings as a means of apprehending the divine. For example, many modern religious thinkers offer interpretations of sacred texts that are consistent with concepts of an evolving universe and the scientific explanation of the Big Bang. Some proponents of a metaphorical reading of the creation narratives allow for a complementary relationship between faith and science. These interpretations claim that science explains the mechanics of the universe, while religion offers insight into its purpose and meaning. Instead, there is a tradition that believes that scientific theories potentially contradict their own creationist narratives. These religions may overinterpret their texts, thereby contradicting established scientific evidence. In such cases, proponents may seek other explanations, such as the idea that divine intervention played a role in the creation of the universe. The Big Bang was an event initiated by a higher power, not a natural event. In addition, the creation stories of some indigenous peoples are closely tied to their understanding of the earth and the natural world. These narratives often emphasize the balance, interconnectedness, and relationship between humans and nature, reflecting their ecological and cultural context. In such cases, scientific theories may not contradict but coexist with these traditions, enriching the understanding of the universe and preserving ancestral wisdom. As awareness of science and cosmology grows around the world, dialogue between the scientific and religious communities is becoming more common. This exchange fosters an environment where both fields can inform each other, allowing for a better understanding of humanity's place in the cosmos. Ultimately, the reconciliation of creation myths with scientific theories remains a dynamic and evolving process shaped by cultural context, philosophical inquiry, and the search for meaning in a complex universe. Messages from the infinite world are very important to our understanding of the world, our sense of reality, and our place in the world. The end of the world shows that there is a limit to its size and possible lifespan. This has great implications for events such as beginnings and endings. If the universe has an end, there may also be a real beginning, like the Big Bang, which marks the beginning of time and life itself. This observation may raise philosophical questions about what existed before the universe began, and what will happen when it reaches the end of its evolution. Instead, the infinite universe refers to an infinite space that extends infinitely in all directions and will last forever. This raises interesting questions about the nature of infinity and its relationship to existence. If the universe is infinite, this means that there are many points in space and time, and many structures, states, and even forms of life are possible. This challenges our understanding of the uniqueness and importance of our own existence. If the world is truly infinite, many of the same or similar phenomena could be occurring elsewhere. The concept of an infinite universe also influences theories of cosmology and the structure of space-time. An infinite cosmos could mean that certain physical laws and constants are the same for all, resulting in a homogeneous universe. However, it could also mean that we are in a localized section of this vast space, creating an observable universe that appears structured and finite, while the whole remains infinitely larger and more complex. Furthermore, the distinction between finite and infinite has philosophical implications for the nature of time. In a finite universe, time would have a clear beginning and a potential end, which would make us question the ultimate fate of existence. On the contrary, an infinite universe may imply an endless series of events without definite boundaries, suggesting eternity and cyclical existence. Ultimately, the question of whether the universe is finite or infinite affects not only scientific inquiry, but also existential reflections on the role, purpose, and nature of humanity's consciousness in the vast cosmos. Ongoing study of these concepts continues to shape our understanding of reality and our place in this intricate and mysterious universe. The anthropic principle is a philosophical consideration that suggests that the fundamental properties of the universe are conditioned to allow for the existence of conscious observers such as humans. This principle exists in two main forms: the weak anthropic principle, which states that the observable properties of the universe must be compatible with the existence of life, and the strong anthropic principle, which implies that the universe must have the necessary conditions for life to evolve at all. The anthropic principle plays an important role in debates surrounding theories about the origin of the universe. For example, when considering a wide range of fundamental physical constants, such as the strength of gravity, the mass of elementary particles, and the strength of electromagnetic interactions, the anthropic principle suggests that if these constants were any different, intelligent life as we understand it would not have arisen. This observation raises intriguing questions as to why our universe has the specific characteristics that it does, and leads to speculation that the universe appears to be finely tuned for life. In the context of cosmological models such as the multiverse theory, the anthropic principle becomes even more relevant. Some theorists believe that our universe is just one of many others, each with its own physical constants and laws. From the perspective of many in the world, it is not surprising that we live in a world where we only see a world like ours in this great world. The concept of love in this case helps explain why unique laws of nature are necessary for life. We live in a world that has evolved in a way that is beneficial to our lives. In addition, the principle of compassion also gives rise to philosophical statements about purpose and life. This raises the question of whether the objects of the world are random, or whether there is a deeper design or purpose to them. This interplay between scientific theories of the origin of the universe and the anthropic principle prompts a multidimensional exploration of cosmology, existence, and the nature of life, forcing scientists and philosophers to consider our place in a seemingly vast and finely tuned cosmos. The search for knowledge about the origin of the universe has significant ethical implications that intersect with scientific inquiry, philosophical reflection, and societal values. A major ethical concern relates to the responsibility of scientists and researchers to communicate their findings and theories to the public. As our understanding of the origin of the cosmos deepens, it becomes important to translate complex theories about the Big Bang, black holes, and quantum mechanics into accessible language. Misinformation or misunderstandings can lead to misconceptions about science, potentially leading to distrust or cynicism towards scientific institutions. In addition, the search for knowledge about the origin of the universe raises questions about what it means to be human and our place in the universe. The results that explain our inadequacy in much of the world may seem trivial or frightening. Ethical considerations arise regarding the public's attitude towards these findings. This raises questions about what it means to be human in a large, seemingly irrational world, and how we shape our values, priorities, and attitudes. Determining the emotional and ideological implications of these findings requires a deeper understanding and discussion encompassing different perspectives. Another aspect relates to the ethical implications of resourcing and funding cosmological research. Because ambitious projects such as large particle colliders and space telescopes require significant investment, society must weigh the benefits of this knowledge against pressing social concerns such as poverty, climate change, and health care. Arguments about the priority of scientific research in cosmology over meeting immediate human needs can be contentious, emphasizing the ethical obligation to balance the thirst for knowledge with responsibility to humanity and the planet. In addition, the quest to understand cosmic origins also leads to ethical discussions about the potential implications of our discoveries. As we study the fundamental nature of the universe and manipulate concepts at the quantum level, we must consider the moral implications of the technological advances that may emerge from this knowledge. Advances in areas such as quantum computing, artificial intelligence, and space exploration present both opportunities and risks, requiring a proactive approach to ensuring that such technologies serve humanity rather than exacerbating existing inequalities or creating new ethical dilemmas. The quest for knowledge about the origins of the universe raises critical ethical considerations, from the responsibility for scientific communication to the impact of discoveries on human understanding, resource allocation, and moral implications. Consideration of these ethical dimensions is vital to fostering a responsible and inclusive approach to our space research. Our understanding of the beginning of the universe has a profound impact on how we envision its possible end, shaping both scientific theories and philosophical reflections. The Big Bang Theory posits that the universe emerged from an extremely hot and dense state about 13.8 billion years ago, introducing the idea of cosmic evolution in which the universe has been expanding ever since. This seminal event lays the groundwork for exploring possible scenarios for the future of the universe and the ultimate conclusions. One important way in which this understanding shapes our views about the end of the universe is through the concept of cosmic evolution. Just as the universe began with an abrupt expansion that led to the formation of galaxies, stars, and planets, many cosmological models envision different ultimate fates that may follow this expansion. These include scenarios such as the Big Freeze, in which the universe continues to expand indefinitely, resulting in a cold, dark, and lifeless cosmos. The Big Bang, in which gravitational forces eventually reverse the expansion and collapse the universe into a single state, or the Big Rip, in which the acceleration of the expansion of the universe tears everything apart. Each of these outcomes reflects the continuity of processes that began with the Big Bang, which allows us to view the universe as a dynamic entity subject to the laws of physics. In addition, understanding the beginning of the universe raises fundamental questions about time, causality, and existence itself. If the universe had a definite beginning, then considering what its end might look like becomes a natural extension of our exploration of temporal boundaries. Ideas related to entropy, particularly the second law of thermodynamics, help us understand how energy dissipates and systems evolve toward disorder. As the universe ages, entropy increases, leading to discussions of heat death, where all energy is evenly distributed and there is no energy left to support processes that can sustain life. From a philosophical perspective, knowledge of the beginning of the universe influences views of human existence, meaning, and significance in the grand cosmic narrative. If we recognize that beginnings and endings are integral aspects of the life cycle of the universe, it prompts reflection on the purpose and transitory nature of life in this vast structure. Such consideration fosters a deeper appreciation of the present and the connections between all forms of existence, emphasizing the importance of understanding our place in the cosmos, regardless of how it may ultimately end. Ultimately, the interplay between our understanding of the beginning of the universe and its potential end drives ongoing research in the field of cosmology, prompting questions about the nature of time, existence, and the fate of all matter and energy. The exploration of these complex topics inspires both scientific and philosophical endeavors as we seek to comprehend the forces that shape the universe and ultimately determine its fate. Human consciousness plays a key role in observing and understanding the universe, influencing how we formulate questions, develop theories, and interpret data from our investigations. As conscious beings, we have the unique ability to reflect on the cosmos, searching for meaningful patterns and ideas amidst the vast complexities of space and time. This conscious engagement allows us to shape our understanding of the universe through scientific inquiry, creative thinking, and philosophical inquiry. Our observations of the universe are inherently tied to the limitations of our senses and the tools we develop to extend those senses. From ancient astronomers who used the naked eye to modern astrophysicists using powerful telescopes and particle colliders, human consciousness has been driven by the desire to expand our observational capabilities. However, the interpretation of observational data depends on our cognitive processes, cultural traditions, and existing paradigms. Theories about cosmic phenomena such as black holes, the Big Bang, or dark matter are constructed through the lens of human understanding, which inevitably entails biases and assumptions. In addition, consciousness inspires the philosophical reflections that accompany scientific discovery. For example, as we explore fundamental questions about the origin of the universe, the nature of reality, and our place in it, we are confronted with deep existential questions about purpose and meaning. This interplay between scientific discovery and philosophical reflection shapes our collective worldview and determines our relationship to the cosmos. When we try to make sense of concepts such as the anthropic principle or the implications of an infinite universe, human consciousness becomes a crucial factor in how we find meaning in our existence. In addition, human consciousness leads us to question the ethical implications of our advances in understanding the universe. As our knowledge of cosmic phenomena deepens, ethical considerations emerge concerning our responsibilities as stewards of the planet and participants in the unfolding narrative of the cosmos. This moral dimension reflects a growing awareness of our interconnectedness with the universe, prompting the pursuit of knowledge not only for its own sake, but also for the betterment of humanity and the preservation of the environment. Human consciousness is integral to our relationship with the universe. It drives our pursuit of knowledge through observation, interpretation, and reflection, shaping our understanding of cosmic phenomena as well as prompting important ethical considerations. The relationship between consciousness and exploration of the universe enriches our journey and emphasizes the significance of our quest for knowledge in determining our place in this vast and mysterious cosmos. The concept of causality is fundamental to our understanding of physical phenomena and events, generally assuming that every effect has a preceding cause. Intriguing complexities arise when applying this principle to the origin of the universe, especially in the context of the Big Bang. The Big Bang represents not only the beginning of the universe as we know it, but also the origin of space-time itself, leading to profound questions about how causality operates in such an unusual context. Traditionally, causality implies a linear progression, where events unfold in a temporal sequence, with clear antecedents leading to consequences. However, when considering the Big Bang, determining what might have happened prior to this event becomes a challenge because time, as we understand it, began with expansion. Within this framework, the concept of causality as we know it can break down, giving rise to speculation about whether conventional causal relationships can be applied when discussing the origin of the universe itself. Some theories, such as those involving quantum mechanics, suggest that the universe may have arisen from a state without classical causality. For example, quantum fluctuations in the vacuum, potentially arising from the concept of quantum foam, could be the mechanism for the birth of the universe. In this scenario, the concept of cause and effect may stem from the fundamental uncertainty inherent in quantum states, allowing the universe to spontaneously generate without an apparent cause in the traditional sense. In addition, alternative models such as cyclic theories or multiverse theories offer different views on causality and the origin of the universe. Within this framework, the universe may undergo repeated cycles of expansion and contraction, or our universe may be just one of many in a larger multiverse, each potentially influencing the other in ways that challenge our linear understanding of causality. In this case, events could become interdependent and interrelated across multiple universes or different cycles, further complicating the notion of a single linear cause. Ultimately, exploring the concept of causality in relation to the origin of the universe raises profound questions and challenges our traditional frameworks. This is prompting scientists and philosophers to rethink the nature of existence, time, and the causal relationships that underlie our understanding of reality. As research progresses and new theories are developed, our understanding of causality and its application to the origin of the universe is likely to continue to evolve, reflecting the complexity of the cosmos itself. The limits of human knowledge in understanding the origin of the universe present both philosophical and scientific challenges that reflect our cognitive and observational limitations. One significant limitation lies in the nature of the universe itself. The conditions that prevailed at the very beginning are such as those that prevailed at the time of the Big Bang. As a result, under extreme temperature and density conditions, our current physical theories, in particular the general theory of relativity and quantum mechanics, cannot provide a consistent description. This intersection of physics challenges the completeness of our theories and ultimately limits our ability to fully understand the circumstances surrounding the origin of the universe. In addition, our quest is complicated by the concept of time beginning at the creation of the world. Before the Big Bang, traditional notions of time may not have applied, and discussing time before the Big Bang has been a real challenge. This creates a huge barrier to our understanding as we rely on moments to identify and understand events. If the creation of space and time as we know it does not exist, our understanding of its origin will be very limited. Mental limitations are also important. Our brains are designed to navigate and understand experiences on relatively small and manageable scales. Concepts such as infinity, the vastness of space-time, or the behavior of quantum particles challenge our intuition and mental models. These complexities require abstract thinking and complex mathematical schemes that even trained scientists can find difficult to fully visualize, limiting broad understanding and engagement. In addition, cultural and philosophical views can introduce subjective biases that affect our understanding of the origin of the universe. The interplay between scientific discoveries and deeply held beliefs about the existence, purpose, and nature of reality can determine the interpretation and acceptance of scientific theories. Consequently, discussions about origins can become entangled with values and beliefs, leading to different conclusions in different cultures and traditions. Finally, there is the limitation of empirical observation. Much of our understanding of the early universe is based on indirect data, such as cosmic microwave background radiation or gravitational waves, rather than direct observations. Reliance on inferences leaves gaps in our knowledge and understanding, which makes us cautious about drawing definitive conclusions about the origin of the universe. The limits of human knowledge in understanding the origin of the universe are conditioned by problems in our physical theories, the conceptual nature of time, cognitive abilities, cultural attitudes, and the limitations of observational data. All of this together emphasizes the pursuit of knowledge and the importance of ongoing research and collaboration across disciplines as we seek to expand our understanding of the world.